So our final speaker for Performance Now 2024 is the fabulous Annie Sullivan. Annie is responsible for the team that brought us Core Web Vitals. Woohoo! Yeah. Thank you, Annie. Thank you, Annie's team. Annie has been working at Google for 20 years. She has seen some incredible changes in the web in that time. Like, could you imagine 20 years in one job? I could never. But anyways, I'm really excited to hear Annie's talk. I hope all of you are too. So give it up for Annie Sullivan.
Well, thanks so much. It's so great to be here with you all today. I've spent the better part of the last 25 years working on performance in one way or another, and being here, it just feels like home. So I'm so happy to be here. And when I got the invitation to talk, I really wanted to take a step back from the day-to-day and talk more about what I've learned over that time about how everybody can be a great performance engineer. But first, I just wanted to take a look back. This is the last talk of the day. I know there's some sad things we saw with excessive JavaScript and third parties, but overall, there's a lot to celebrate. So we had a blog post that launched kind of with perf.now last year, and we calculated last year for the previous year, so 2023, how much time had Chrome users been saved along the Core Web Vitals, and that counts both changes that we made to Chrome to improve it, and also changes that all of you and many, many more people have made to websites and the platforms that websites are built on. And so that was almost 12,000 years in 2023. And that was super exciting and motivating. And so when I came back, I thought it would be great to update the number. I didn't think we'd be able to beat it, but actually we almost 3x'd it. We have saved 30,000 years of end-user time in the last year. That's just absolutely momentous improvement in the day-to-day lives of millions of people. And thank you all so much. This is really, really cool. And I also made this slide. It's been around a lot. But I think what's really cool here, too, is that we have more time right now to spend on that performance equality gap, because dozens of countries are going greener as far as LCP and IMP. So this talk is called Aiming for the Stars. And my idea was to kind of talk about all the amazing performance work that I've seen in my 20 years at Google and my previous teams in video games, and really talk about what I think makes a great performance engineer. But I think one thing that I kind of want to balance when I was talking about this is that not everybody has the chances that we have at Google to just spend full time on performance, to go deep and spend years on an ecosystem effort. I know some of you are struggling even to get your companies to buy in at all. So I thought I would frame the talk around this idea of the North Star. We have a direction that we want to go, and we all try to aim in the same direction and figure out where we want to go. And even if we don't get all the way there, that's OK, because I think all the best work I've seen, including all of this amazing work on Core Web Vitals, has been iterative. And you can't iterate unless you have a direction. So I wanted to talk about some of those directions. I'm doing this in terms of North Star. North Star number 1, have a North Star. So the first thing you should do, if you haven't already, is choose a North Star. A North Star is an overarching goal, something that you might not be able to fully achieve, but that it's a really great vision for your product, for the user experience. So not we want to save X bytes of JavaScript, but more like if we could wave a magic wand and make one thing about our product true from the user experience perspective, what will we do? So on our team, our North Star is that every site on the web has good Core Web Vitals. We think that North Star is part of a broader world where we have a thriving open web ecosystem. And that has really, really been a big deal for the Chrome team at Google. It has really helped us rally around a few straightforward metrics: largest contentful paint, cumulative layout shift, and interaction in next paint. Every time we launch a change, if we want to make a performance improvement, we launch it as an experiment, and we look at the impact on real users, and we understand, like, did it help their core web vitals? When people launch new features or changes that are not related to performance, we see, did it regress their core web vitals? And as we have the same North Star year after year, we get better and better, as you've seen, at making the web fast. And so I think I do want to say that, like, we are, on the one hand, we're making great progress. This is from Core Web Vitals Tech Report that Jason mentioned in his talk. You can just look at all websites, too. And you can see the pass rate on mobile of, the percentage of sites on mobile that are good, Core Web Vitals over time. And on the one hand, both on mobile and desktop, we've doubled it. But on the other hand, we're only halfway there. And that's OK. Your North Star doesn't have to be quite this lofty to have years and years and years of work towards it, but it should be something that you really aspire to. We have done our best to make Core Web Vitals a great North Star. It's supposed to be a good default. But I think you should really think carefully about your North Star. There's a few things you want to consider as you go through thinking about it. One is that, obviously, it represents the user experience. 2, for real users. 3, it should be rooted in business values. And 4, you should be pretty careful about the statistic you report on it. So first, representing the user experience. That's really, really important. Obviously, the user experience is what we all care about. And a really, really great lens for thinking about user experience is what's called a critical user journey. A critical user journey is just like the set of tasks a user goes through to complete like a key task in your product. So for example, they go to the homepage, they click product listing, and then they click a product and hopefully buy it. I think this is a really important concept to be thinking about as you're writing a North Star metric, like what are the critical user journeys for your product? But if you think through this a little bit and you try to make like a metric that represents like this journey, a lot of things get mushed together, right? Page loads and interactions, and if you try to make it like all just a big gob together metric, weird things like drop off in the journey could increase the metric. A lot of people, for a lot of reasons, not just performance, have come up with a way to break this down into the idea of a critical user interaction. And critical user interactions are just the steps in a critical user journey. Core Web Vitals measure critical user interactions. But if you think of them as part of your critical user journey, it could help you prioritize. Like maybe instead of having the 75th percentile for all page loads, you would split up the home page, the product listing pages, and the add to cart page. Or maybe you would measure like the add to cart and the buy now button at higher priority than the rest of the things that contribute to IMP. So sometimes your application is complex enough, and I think we've heard a lot about this over the last 2 days, that maybe the core web vitals don't quite align with your own critical user interactions. We are measuring very specific critical user interaction, a page load, the first response to a user input, and the stability of the content. So what if you need to measure more? I think there's several things that you can consider. A lot of the different APIs from the Web Prep Working Group work really well here. When we were making LCP, we did anticipate that this was going to be an issue, and we implemented the element timing API at the same time. That'll give you the timing of anything that's contentful according to the largest contentful pane API. So anytime you're thinking about like when did this show up on the screen and it's not quite a page load, that's a great go-to. I also would refer you to Jason's talk about the way that Bloomberg is extending this API with the container timing. We're really excited about that. Similarly, for event timing, you don't have to measure the IMP. You could measure any interaction. And you might think about which ones are more important to you. I also wanted to call out the long animation frames API here specifically. I know we've seen so much cool stuff from run providers about the long animation frames API and how it gives us attribution. It can tell us which scripts are slow, and it's even like convinced third parties to fix stuff. That's all super cool. But taking a step back, what the long animation frames API does is it kind of models the event loop. And so if you're thinking about you want an application that's very smooth, you have like a lot of frames that you're producing, especially on the main thread, the long animation frame will give you every frame that takes more than 50 milliseconds. So you can see when things are choppy and not smooth. So that's one you should definitely look at. And there's tons and tons more APIs that you can put together. And one other thing you can do is stitch them together through the user timing marks and measures. That can get reported to RUM. It can get shown in tooling. Jack showed a super cool demo of how it looks in DevTools. So those are some things to be thinking about. But I did specifically, especially call out element timing, container timing, event timing, because they measure when something is shown on the screen. And we do think that's really important to keep the focus on the user. All right, so now we probably have an idea of like what are our critical user interactions and journeys. It's also super duper important to measure for real users. So the easiest way to do this, if you have the resources, is real user monitoring tools. They're amazing. There's tons of real user monitoring vendors here. They give you a dashboard that updates really fast, and you can slice and dice the data. It's fantastic. If you don't have that set up yet, a quick start is a Chrome User Experience Report. It's really fantastic at getting you an idea of what are your actual core vitals seen by end users. OK, but what if you're actually just making the site right now, or you don't have any traffic, you can't get RUM or Chrome User Experience Report? So I think the best thing to do is to think carefully about what your user base might be like, what would their devices and network connections be. Really try to get a low-end device, like a low-end Android or a netbook, and test your site out on that. But if not, you can fall back to the DevTools throttling. So here is an example of opening the DevTools and using the throttling. And you can see, like, I tried to make this page really slow by setting the throttling pretty high. And you can get an actual feel for, like, what is a 7-second page load actually feeling like. And no matter how much RUM data you have, how great your data collection is, I really encourage like each and every one of you to just try it, to see like what are your high percentile users and devices, to click on your site, and see how it actually feels. It's really important to have that empathy with end users. OK, another thing you should be thinking about, performance engineers don't define user experience in a vacuum. We're part of a business. And ideally, our metrics are rooted in business values. So Tammy mentioned this at her talk. She has an awesome blog post that I linked about how you can correlate your metrics to your actual, your performance metrics to your business metrics. Getting aligned with the whole organization on what are the critical user journeys and the business metrics, I think, is really critical to getting buy-in across the organization and getting everyone swimming in the same direction, which has been a really key component of every successful performance project I work on. Finally, you want to choose a percentile. So what about the 75th percentile? Annie, didn't you just tell everyone in the world that they should use that? Yeah, so Core Vitals does use a 75th percentile. It's a good starting point. I want to take a step back and say, why does Core Vitals use a 75th percentile? So let's take another step back. What is a percentile? So it's that percent of your users have that score or better. So at the 75th percentile, if it's 3 seconds, then 75% of your users have a score of 3 seconds or better. Obviously, like the higher the percentile, the more of your user base you're capturing. So one thing is that, like, how many percentiles should we show? For all of our tooling in Chrome, we choose to show 1 percentile, because people think it's really confusing to throw tons and tons of numbers at you. We don't want our dashboard to look like those really awesome Bloomberg ones that maybe not all of our customers are traders, right? So we toned it down. We just go 1 percentile. And one thing that was really critically important to us is to be inclusive of the smallest sites we possibly could. And if you're on the smaller end of our data set, like one user zooming into a subway tunnel as they load your site is going to kill your higher percentiles. So this is a trade-off. We have a number that represents most of your user base, but it also ignores outliers. But I think you should consider going higher with your percentile. We on Chrome, so yeah, one stat that I was going to say is that like if you just Google like how many page loads does the top 10 websites have, you can understand really quickly that the 99th percentile for one of the top 10 websites is translating into like that experience is experienced by tens of millions of people every single day. So at Google, obviously, we track the 99th percentile, and we track it in Chrome. And I think you should really strongly consider it. We also did a study. We have had an argument, right? The 99th percentile users, they're zooming into a subway tunnel. They're slow. They're on bad devices, on bad networks. And so we actually did a study, and we found that it's not just one user group that experiences this terrible performance. It's a lot of people experiencing a little blip once in a while. And that's something that you should really care about, because in many, many products, a very slow experience can be a retention problem. Users will leave a product that's too slow if they can. OK, so how do you actually go about deciding a percentile, and if your 99th is too noisy and whatnot? I highly recommend looking at histograms. One thing that's really, really cool, and where this data came from, is a Chrome user experience report actually has full histograms in BigQuery of all of the site it reports on. And if you don't feel like being like me and doing a BigQuery collab, shout out to Treo. They have awesome histograms. But here's my BigQuery-based one, and it's 2 histograms, right? The blue is a desktop, and you can see it's faster, right? It's got a peak at around 600, 700 milliseconds, and then it drops off pretty quickly. And then the yellow is the mobile, and you can see it has a pretty heavy tail. It drops off really slowly. And so the bars are 75th percentile overall and 95th percentile overall. So you can see for this data, the 95th percentile really captures it a lot better than the 75th. But this isn't a super popular site. The 99th is over there at 12,500. It might not actually be worth it for this site to go all the way to 99th. 95th might be good. So looking at histograms can really give you a clue of what you're measuring. And I'll just say try looking at histograms and slicing and dicing them. This is an interesting one I found when I was just querying the data. You see there's a little bit of a hump on the left and then a big hump on the right. This was called a bimodal distribution. And that's a hint that there's actually 2 distributions here in your distribution of data, right? If you look at the navigation types in Crux, you'll see that the little hump is BF cache navigations. Tim gave a really awesome talk last year, Tim Vreek, about optimizing different parts of your site, and he recommended to kind of split that out when you're optimizing. And I think this is something that I see a lot of people get confused about. Oh, let's split out BF cache, let's split out mobile and desktop, let's split out different countries. That is great for debugging and optimizing, and I think Harry used the word enabling metrics. But when you're talking about a North Star, you want as few as you can, and you just want to really report as best you can what's the user experience. So recap. A North Star represents the user experience for real users. It's rooted in business value at a carefully chosen percentile. North Star number 2, understand the bottlenecks. OK, so I think this is one thing that I see over and over for great, great performance engineers is they dig in and they really understand what is slow about their app and what can we do about it. And there's some really fantastic writing by Philip Walton and by Jeremy Wagner on IMP and LCP. Since that's pretty relevant to this group, I thought I'd kind of cover it to show you what we mean by bottlenecks, and especially how a bottleneck works out in a browser. So here's the LCP breakdown. We call it the Walton breakdown after Philip. So the first part of the breakdown is the time to the first byte. You have to get a response from the server before you can do anything. And if that takes too long, the whole thing takes too long, right? And then this is called the resource load delay. So we have in purple some CSS files loading. And I think when I first started working on LCP, and I think what a lot of people think is you have an HTML document, it has an image in it, and then the image displays. Not usually this simple. So most of the time, the image might be in a CSS file, or it's injected in a JavaScript. And one time, we actually found a page that was a JavaScript file, loaded a JavaScript file, loaded a CSS, et cetera, at 6 hops before this image can start loading. And so if you think about resource load delay, that's trying to give you an idea of the bottleneck. So right now, we're waiting for these CSS files to load because they're on the critical rendering path. And only then do we start loading the image, which is in the CSS. then obviously we have to wait for the image to load. But wait, there's more. All of this JavaScript that is running, when the image is loaded, the main thread is still busy in an event loop. And we have to wait for it to be not busy for it to display the largest contentful paint. So if there's a bunch of JavaScript running while it loads, we have to wait for that. And so we can see through this graph that there's a whole lot of potential bottlenecks that we'll want to understand and look for. And it's the same with IMP. Jeremy has written like really awesome articles about this, but I just added some new trace events to Chrome, so I'm going to ignore Jeremy's way better diagrams and go with mine. All right, so this is a click event handler. And before Core Vitals, I think a lot of people were thinking about the performance of their interactions in terms of the click event handler, which honestly makes a lot of sense, right? But the full interaction time is this. From the time the mouse is clicked, through the event handler, through a bunch of other stuff, until it finally gets presented to the screen. So what's the other stuff? We have a script that's already running, and it needs to finish before our click event handler can start. But then on the other side, we're part of an event loop. And the event loop always needs to run a request animation frame, style and layout, render, and resize observers before that animation frame can run. So this is actually what the long animation frame API is meant to kind of conceptualize, is these animation frames in the event loop that have to run. So it runs all the scripts, including the event handlers. Then it does the rendering style and layout. And then it also has to go to the compositor process, which is kind of not pictured. So you have to be able to think about all the different bottlenecks and not just your specific event handler. OK, so that's all well and good. Do you want me to go read the blog post and dig into documentation, learn about the critical rendering path and the event loop? That would be great. But what I think a lot of really, really fantastic performance engineers do is they learn to use the tools so that they can dig into this and understand it themselves. And I think it's the best way to learn about how the browser works. Sorry. Real quick. And when I talk about tools here, I want to kind of split it out. So a tool like Lighthouse that audits and tells you kind of what do you need to do, what's broken on your page, and what should you fix. Those are amazing tools. They're fantastic. Paul gave a really convincing talk just yesterday about how almost any site could benefit from those. But what if you wanted to be like Paul and come up with these things that are wrong that may not be in the tools? That's when you need to dig deeper and understand those bottlenecks. So one of the things that I see that are really, really common in tools, if you go back, we have all of these boxes, right, that I'm showing, and they're called spans. And then we actually have these things called tracks. So we have a ton of tools that have spans and tracks, and Chrome DevTools is one of those. Jack gave this amazing talk about how they're working really hard to simplify this down and focus things in here. But I want to take a step back and say, what if we don't know what to focus on yet? What if we have to dig into our own critical user interaction? How do we even start? Because this is very complex, right? And the reason it's complex is because it shows a lot of information. If they took some of this out, then you would be able to do less. So what do we do? How do we figure out how to get around in this thing that has so much information? First off, we break it down into tracks. The whole thing is just a series of tracks. So up at the top here, this is very, very common in a tool to have a top-level track that helps you get your bearings. At the very top, it has a timeline for the whole trace, right? So it takes about, sorry, I can't see, almost 6 seconds, 5,500 seconds. So you can see, what is the whole thing? Then Jack talked about this more. We have these cool sliders that let you zoom in and out in different parts of it. And then, so we are zoomed in right now. If you look at, you can compare the timestamps on the thumbnails to the timestamps on the left and right. It shows how, the bottom timeline shows how zoomed in we are. And then we have the main thread activity shown here. And this is pretty cool. It lets you think about what might you want to see. Probably those giant blocks of orange, or yellow. Those are JavaScripts. Those are interesting. I'm kind of curious, what is that tiny mountain of green? but that kind of helps you find like if you don't know what to look at. And then also there's a row of screenshots that you can hover over. So if you're looking for like a specific interaction or thing that's happening, you can use those. So all of this is about finding your bearings. Then there's the network panel. Again, it's got a ton of new features. It can show you like all sorts of cool stuff if you click and hover. This is a more detailed frames panel that can give you all sorts of information about the smoothness of animations, when did frames drop, and what was rendered when. This is a second animation panel that thinks of it in terms of like the animations as opposed to in terms of the frames. This is a really handy panel that will give you like so your user timings and your web vitals. The user timings panel, is that what it's called? Timings panel, yeah. And then the main thread track, I think, is where we want to focus a lot of our attention. So we've been talking about JavaScript. Is it good? Is it bad? Is it useful? This is where JavaScript runs in all of the yellow. But there's also other things that have to run on the main thread. Remember, I talked about that event loop and like CSS and Java and rendering like the purple and green there too. So this is one of the tracks that we're going to spend a lot of time on. But first, I think it's really important to learn to navigate the panel. I think whenever I try a new tool like this, I just go in and like take a big trace and mess around, right? Like, what does the mouse wheel do in this tool? Like sometimes it zooms, sometimes it scrolls. What happens when you click on stuff? Most of the time you'll see a little box underneath it. What do the scroll bars do? The arrow keys. A lot of these tools, like, do you guys remember video games with WASD? A lot of these tools have WASD support. Check that out. And obviously use those sliders and all the amazing stuff that Jack talked about, of course, to find your place from the Insights panel. OK, then the next thing you want to do is just close everything you might not need, because there's so much information. And the reason that we have tracks is because we have too much information. Almost nobody uses all the tracks at once. So we just want to get rid of the stuff we're not interested in and focus on the rest. If you right-click on a track, you can actually close and reorder them. I think it's new, right, Jack? Yeah, it's pretty cool. They've been doing amazing work here. All right, leave yourself some signposts. This is the second part of getting around. So first, when you're first learning the tool, there's a couple things that I always do to make sure that I can understand like what the heck is going on. Harry was telling me he wasn't sure if the Chrome memory tool works, so he made an array that allocated like a ridiculous amount of memory, and then he could see it, and then he knew it was going to work. And same here, right? If you add, like here, I just added a script with the 5-second busy loop, and I could definitely see, like, OK, I've got a 5-second busy loop. I know where it is. I can find it in the tool. It does what I think. Another thing you can try is just a really short session. Like open the DevTools, click record, do something, click close, and like, can you find the thing that you did? Jack pointed out annotations. Those are super helpful as you're going from like just experimenting to like trying to actually navigate your way around a real trace. OK, but in the real world, we're not going to constantly add busy loops to our code. We actually want to debug it. And the best signpost that we can use to do that is user timing. So I think we all know how to add marks and measures. And Jack gave like a really, really great example of how to do that. But I can't emphasize this enough. If you do have like a place in your app where you're trying to debug this certain here to here, how helpful this can be, right? To just add a custom span and show it, right? It doesn't have to be like Daniel added those really cool spans to view. It doesn't have to be like this production thing that everybody can use. It's a really great like one-up to the printf. So definitely try it. And also, if you press Control F in DevTools, you can find the spans that you added. And that's a really common pattern I see performance engineers do, like find the thing and scan through until you find the one that you want to look at. OK. So now we know how to use the tools, but how do we actually see the bottlenecks? So again, you want to mark off somehow, whether you already have an LCP or whether it's a custom user timing, the start and end of your critical user interactions. And then you want to find things, right, that are going wrong. And a couple of things that go wrong is very long bars, right, like things that take a really long time. Things that clearly happen in serial instead of in parallel. And also, sometimes when things are going wrong, it's a gap. So here's an example that's not like a really bad problem, but it just helps illustrate what Phil was saying about LCP. So We have this main thread, it's running, and then before we get our LCP, it just stops. It's completely blank. Nothing's happening. What's going on? That CSS file that we started loading is render blocking. So we can't actually keep going with the page until the CSS finishes. The reason there is, I don't know if you all heard of Flash of unstyled content, but if we styled the page and then the CSS loaded and then we restyled it, that's bad. So that's why CSS in the head is render blocking. And if you look at the timings, like that's like what, 10 milliseconds? It's not a problem, right? But it's just a good example of like when you can see like a gap and whether you expect it. Now I have an example of a long bar. So here, I didn't mention earlier, we also have an interactions track that can help you get your bearings on IMP. So this like dashed red line that's really long is a long keyboard interaction, 800 milliseconds. And then underneath that, you see this like super long bar. OK, but commit. Like, what's commit? OK, it's green. And then if you look at the bottom, green is painting. OK. Now we're like not sure what to do, right? Because it's just green, painting, commit. OK. The next thing you want to do is add your tracks back in, focus on this thing, and scroll up and down and see what else might be happening in the other tracks. And when you look, you get to the thread pool track. It's got some green bars, and then you expand it, and you see this. Image decode. And this is really cool. Number one, we know like this an image is a problem, but also it actually links the image here. So you can click on it, and if you do click on it, you get an image that's like, if this is my laptop, it's as big as this stage. And it was actually meant to be an icon. And I have seen that like recipe sites do this a lot too. So that's kind of a thing to know about, right? Like you learn as you go. But it's an example of finding a bottleneck that's a long bar. OK, so we found our bottlenecks. We're getting used to the tools. I think it's really cool. What's the next North Star? Oh, I forgot. Sometimes you have these gaps, and the whole DevTools just doesn't show you the gaps at all. Chrome also has its own tracing tool called Perfetto, which is like the IMP events that I was showing you. We also just launched this really cool thing where it can automatically collect traces on slow events while you're browsing. And then those can be loaded either in Perfetto or in DevTools. But in Perfetto, you have like tons of information. So if you need to dig deeper, Perfetto is where you go next. And it has the same tracks and overview and spans and everything. It's definitely like that model is worth getting used to. All right, now we're good at bottlenecks. North Star number 3, get awesome at experimenting. OK, so like I feel like I made it down pretty straightforward so far, right? You get a goal, you find the bottlenecks, you fix it, right? But I think if you're more experienced people in the audience are like, well, it's not that simple. A lot of times, so again, we want to improve things for real users, and real users they're crafty, right? They have different networks and devices. We've talked about that. But even though we just said what our user journey is, sometimes they do something else, all sorts of different things. And you're not ever really sure if you actually found the right bottleneck or if you actually found the right way to streamline it. So what do we do? The best performance engineers I know? Experiment. Oops, I forgot part. So what can we do? Oh, no, I was going to. Sorry. All right, so the first experiment that I would encourage everyone to do early and often is just try ripping stuff out. Jason gave a really good talk about, and I think a couple other people mentioned, just ripping out the third parties. You can do that with web page test experiments. You can do that with DevTools. Oh, Jack mentioned it. You can do it in DevTools, block anything you want. You can also go and look at a bundle analyzer like Vue or any other bundle, look at things that might be weird, and try ripping them out. I think this, sometimes you get super lucky and you actually just didn't need the thing at all. Like Alex gave some examples. But maybe you do need it, right? And then ripping it out actually gives you a really solid timeline of like, is this actually a bottleneck, or is this just a thing that I don't want to load too many resources? Ripping things out helps you validate really quickly whether you found something that's important or whether you want to move on to something else. But once you have done this, you've identified the bottlenecks, you've experimented, pulled things out, mess with your app. You have a good idea of what you want to do, and you probably actually want to re-architect. You have some cool new component architecture that's going to make everything better. And the problem is that those things always kind of take 2 years, and then at the end of the 2 years, it found a lot of complexity that you didn't realize was there at first, but you had to add it all back in, and the performance is the same. So what do? Keep experimenting. Try to make as small and iterative a change as possible, and then just keep going around in a circle. Make a change. Focus on maybe just one part of your critical user interaction, of one example. Take out your cool idea, try it, measure it, and learn from it. Keep going around in a circle. OK, so I think one of the most critical parts of experimenting, and just one of the most difficult parts of performance work where you're really impacting real users, is actually knowing whether the experiment worked. It's just so hard, right? Users just do the darndest things. And you can't always be sure that things worked out. What really brought this into focus for me was this really cool opportunity. I got to join one of the best front-end performance teams I've ever seen is about 15 years ago. I got to join Search front-end. And they measured their real user page load times at the 99th percentile. And they could identify at that 99th percentile pretty much all of the root causes of shifts up to 15 milliseconds for real users. And that was amazing. How did they do it? Everything that launches on Search launches as an experiment. If they had a performance optimization, they would run an experiment, get the data from real users, usually find out that it wasn't what they expected, tune it, and repeat. If they had a feature launch, they would run it as an experiment, and they would get the data. And if there's a regression, they would try to figure out what happened, or report that it's 15 milliseconds or whatever. And this was just super cool. And when I joined the Chrome team, I was one of a group of people that was really, really excited about the idea of bringing this to Chrome. And as part of a much larger group, I was able to help make this happen and help us get metrics like the core vitals that we run every experiment on. And this is just I just can't emphasize enough how big of a part of those improvements that I showed you at the beginning, being able to do these experiments well, is. And then I think this is the biggest disconnect that I see when I start to talk about this, is experimenting is really A/B testing. You have an experiment group and a control group, and you want to get the numbers for both. And A/B testing frameworks do that, right? But they do it by usually on the client, they inject some treatment, and then at layout shifts, it can be really slow. Isn't that bad, Annie? Yeah, that's why it took so long to get to get this working in Chrome, right? Is you actually want to have a server-side solution that does it all with really negligible performance impact. So right, we'll all go back to work on Monday and rate negligible performance impact experiment frameworks. OK, doesn't always work out, right? But I do have some ideas for you, and I think this is one thing where I would love to tag me in on Blue Sky. I would love to hear your ideas and your thoughts on what's worked for you. I know that a lot of A/B testing frameworks can work in edge functions. If you Google your platform and A/B testing, you'll probably find some interesting stuff. Tim Kadlec wrote this amazing article about, it was on Netlify, but about using a branch to split between traffic. And he actually went all the way through logging run data in speed curves, so you can get some screenshots of what that might look like, which is really, really helpful for just kind of working through what does this even look like. A really, really cool case study that I saw as well is Vodafone. They optimize their page, and they are using ads. They have landing pages. They just sent the optimization for one landing page and the non-optimized for the other, and they were able to show huge revenue impact in addition to the performance impact. So those are some of the ideas I have for solving that problem, but I would really love to work with you all on how can we do it better. Which brings me to North Star number 4, contributing to the community. This is just such an amazing and awesome community, and I've seen so many people with so many great ideas, so much exciting stuff. I really love to see people contributing back. And so I had some ideas on how to do that. I think Daniel also mentioned the ecosystem performance effort. It's E18E because there's 18 letters between the E's. They're doing all sorts of really cool work to improve JS package performance. And I think like something that hopefully is clear is like if you optimize one of those packages that Daniel mentioned, right, that like tons and tons and tons of people use these packages. So like lots and lots and lots of websites will get faster. So that's a really cool thing to contribute to. I'd love to see people looking at these tooling gaps. Even if you don't feel like you can make your own open source tool, like blog about how you did it, make a video. I think I'd be really interested to see how people are solving that problem. Another thing that I think feels really intimidating, but it doesn't have to be that bad, is to actually like help out with the browser. There's people not only from Chrome here, but also from Firefox. And if you're interested in contributing, there's a couple ways that I think that, if you don't have like C++ skills and you're feeling a little nervous about that stuff, if you just have front-end skills, there's a ton of stuff you can do. So Michael Mockney and I are working on soft navigations. I forgot to crawl that out too on the critical user interaction slide. That is the missing one in Core Web Vitals, and we are working on it. So if you're interested in that effort, come talk to me and Michael afterwards. But one thing that we can use help with is web platform tests. If you're not aware, the way that we know whether APIs work or not, especially in a cross-browser framework, is this thing called web platform tests. They're all HTML and JavaScript, and they just test whether the APIs do what they should. So that's a great way to contribute, and especially if you have ideas about something that may or may not be covered well by a soft navigation heuristic. Another thing, and I just actually want to go back, like what I think it's been 14 years ago. My very first changes to Chrome back in the WebKit days were to DevTools. I wanted right-click copy URL on the network panel. And what I learned from that is that it's just nowhere near as hard as you think it is. And it's Jack and team have made it 1,000,000 times easier today. DevTools is just JavaScript and HTML. You don't even have to build Chrome to contribute. It's really awesome. And go talk to Jack if you're interested. And finally, the thing that I absolutely wish everybody would do more is report issues. If you're able to file a bug with a reduced test case, that helps us out so much. And it can honestly, like, when people do file bugs and we tell them like what's going on, they seem like really relieved, like, oh, finally, I'm not crazy. This is happening. But also, I wanted to call back to Jason talking about how frustrating it is, right, to continually like tell the third parties get better. I wanted to give the other side of that, right? Like, yes, most of the time, you tell a third party to get better, and they don't. But like, Erwin, I think you actually found one that got better, right? Malta did too. And we actually have had a ton of success recently. Gil put out a case study of a consent management provider that had improved cookie consent IMP. And I think now there's like about 12 of them that have improved IMP significantly. Taboola put out a case study after data came back from long animation frames that showed that Taboola was slow. Now that they have that metric, right, they used it to improve, and they're no longer like an issue. So that's really cool. We've seen some really cool impact in ads. So I think the upside of like, yes, most of the time you'll report the issue and you won't ever hear anything back, is that every once in a while you'll report the issue and then it'll get faster for like thousands or maybe even millions of websites like overnight. And that's really, really cool. And even though this can be really frustrating, I think that's a really important way to keep going. That's all I got. Thanks.